Hi, myself Poornima, Assistant Professor in the Department of Computer Science and Engineering, Government Engineering College, Raichur. I'll be taking you a video lecture on the application development using Python as a part of the 5th semester subject. Already we have seen 2 sessions. Now this is the 3rd session on the classes and objects. So let's quickly go through the contents of today's session. We are going to check on the modifier functions and we'll see some of the errors that might occur while writing a program and while executing it. And then we'll introduce the classes and methods, and then we'll see how do we actually print the objects. So in the previous session we have seen one type of a function. It is on the pure functions, isn't it? So the pure functions, they do not modify the objects which are passed as a parameter to the function. So such functions we call them as the pure functions. But sometimes what happens is we will have to modify the object that is being passed as an argument. Such functions we call them as the modifiers. Okay, so that is what is being given. Sometimes it is useful for a function to modify the objects as it gets as the parameters. Okay, and these changes are visible to the caller. Yes, because when we pass the object to a function, we are actually passing a reference to the reference of an object to the function. So that is why what all the changes that the modifier function does will be visible to the caller. Okay, so such functions we call them as the modifiers. And dear students, it is very important with respect to the examination. So you might get a question on the functions of 2 types of functions, that is pure functions and the modifier functions. So in that case, so you can give the example of a time class which we have seen in the previous session. Now in this case, so I am going to define one function called as increment, which just increments the values of second, minute and hour in order to print the time in a proper format. So for that, so let's go to the Python interpreter. Okay, so I am going to open a file and I am going to check how the modifier function works. So let me open the file. Yes, so this is the file, the function, the class, so which we have used in our previous session. So same thing I am going to use it now. Okay, so let me keep the all the topics, okay, what we have seen for the session 2. So I'm just adding one function called as define increment. Okay, definition of the increment which takes the object time and this. Okay, let me represent it as s for simplicity. Okay, so what this does is, first it adds the second value s, okay, to the second of the time object and checks if it is greater than 60, then seconds will be modified, and similarly minute will be incremented by 1, okay, and then hour will be incremented by 1. So based on these conditions, so the increment function will modify the time object. So that is what I'll just show you. So time dot second plus equal to 60, isn't it? That is what we do it, not 60, sorry, it is s. Okay, and then we'll check if time dot second is greater than or equal to 60. So if so, what do we have to do? So we have to reduce that value. For example, time dot second minus equal to 60. Okay, and then we have to modify the minute also. So time dot minute plus equal to, so what we increment it. Then again we check if time dot minute after incrementing, if it is greater than or equal to 60, same thing, okay, holds good for minute and the hour. So the way how we have updated, just it is we are changing the value. Okay, time dot minute minus equal to 60. Then time dot r plus equal to 1. Okay, so this is how it is. So now let's try this same. Okay, I have created one time object. Okay, initially r is 9 and minute is 45, second is 00. So and then we'll call the print time. Okay, so this is a print time. So now time being, let's keep it as a function. Okay, which just prints the values of hour, minute and the second in the proper time format. Now let's check. So print before addition. Yes. Now what do I do is, I'll call increment function passing the object time, and for example I'll pass the value 30 and then let's print after addition. Let's quickly run this. So now what is that output I should get it? I should get it as 9:45. Okay, seconds is 00. So after the addition, so what I should get it? 9:45 and 30. So let's check whether our program is working in that way. Oh, the print underscore time actually it takes the object. Okay, so I'm going to pass the time. Here also I'll pass the time object as a reference in order to print the values. Yeah, see now, see the output. So before addition it was 9 hour 45 minutes and 0 seconds. After addition 9 hour 45 minutes and 30 seconds. So what actually has happened here is I've passed the time object as a reference now. Okay, so this reference now is trying to modify the object values. So who is modifying? The increment function is modifying. So that is why we call the increment function as what? It is the modifier function, because it is modifying the time. So as a result you can see the changes of the time object which has been modified by the increment. So let's pass one more value. So I'll pass it as a 60 now. Okay, what it should be now? 9 hour 46. It should print 9 hours and 46 minutes. So let's check the value. Okay, yeah, so sorry, I changed it to time here. Okay, so that self and all, let's check in the next the slides. So timing, try to understand. Okay, yeah, see now, so 9 hour 45 minutes, 9 hour and 46. So that is what it is. Okay, so it is working now. So increment is of type a function modifier, okay, which is actually modifying the time object. Now next we will see debugging in this case. Okay, a time object is well formed if the values of minute and second are between 0 and 60. Okay, and if r is positive. So r and minute should be integral values, but we might allow second to have a fraction part also. Okay, so when we have such requirements, okay, so we have to check some invariants which help us to detect such errors and their causes. For example, you might we might have a function like valid underscore time which takes a time object and returns false if it violates the invariants. For example, so before doing the addition or before printing it, it checks whether this is a valid time, because we know that the time should not exceed more than 24 okay, in a number, and r is 12, 1 to 12, and minute should be 1 to 60, and seconds also should be 1 to 60. So that is why, so such kinds of the validations can be performed here as a part of the debugging process. Now the same thing has been written here. If you see, one function has been written, it is called as a valid underscore time. Okay, so it checks if time dot r is less than 0 or time dot minute is less than 0, or time dot second is less than 0, it returns false. It means that if you have passed any negative value for either for an hour, for a minute or for a second, so it returns false. Okay, and there is one more case also. If minute is greater than or equal to 60 or second is greater than or equal to 60, then also it returns you false. In all other cases it returns, okay, if these two cases are not true, in that case it returns the true value. It means that the time is valid. Okay, so similarly, so whenever we add two values here, the two time values, so in that case before we add it, we have to call this valid underscore time t1 and valid underscore time t2. If both t1 and t2 are represented in the valid time format, then only the add underscore time will add the two times here. So that is what is being shown. So this is as a part of a debugging process which helps us in order to work with the type of a data wherein the time is there. Similarly, we can use this concept for the date also. Okay, so we don't have a month with the date, month with the number 13, and date also we don't have 32, year also we don't have 13. Okay, so like that. So for date and time, so we have to introduce some debugging concepts wherein we write our own functions, okay, user defined functions which checks for the validity of the data. Okay, so now this is also same. Okay, same thing, assert valid underscore time and valid underscore time. Okay, we have assert statement which checks a given invariant and raises an exception if it fails. In the previous we have checked if not, okay, not and all. Instead of that we can directly call, there is a built-in statement, it is called as the assert statement. So what is its duty is, it checks for the given invariant and suppose if it fails, it raises an exception. Okay, and we can write a code to in order to handle such exception. Next, move on to the classes and methods. So all these examples what we have seen either in the session 1, session 2 or in this beginning of session 3, we have written the functions. So the difference here is, as I have told you in the session 1 itself, the difference between the normal functions and the classes functions lies with the name itself. So methods are nothing but the functions that have been defined inside the classes, and the functions are independent, they have not been defined. Now if you look at the previous examples, okay, let me show the example what I have used in this case. Okay, now if you see here, so I have used two functions, one is print underscore time, the other one is the increment function. If you look at these two functions, so what are these two functions? These two functions are normal functions, they are not the methods. If you make them as a part of a class, then they are called as the methods. So in this slide, so let's check how do we introduce, okay, the methods inside the classes. Okay, so the programs can include the classes and method definitions, and most of the computation is expressed in terms of operations on the objects. Okay, and objects often represents the things in the real world as we have seen in the earlier cases, and methods often corresponds to the ways things in the real world interact. When you have the real world, you need somebody, okay, that somebody is nothing but it is a methods which corresponds to the way things in the real world interact. Okay, and method is a function that is associated with a particular class. Yes, methods are semantically the same as functions, but there are two syntactic differences. So what is that difference is? Methods are defined inside a class definition in order to make the relationship between the class and the method explicit. And the syntax for invoking a method is different from the syntax for calling a function. So when we call a function, we directly use the name of a function, whereas in order to call the methods, we use the object, okay, to invoke the method or to call the method. The way how we access the attributes or the variables of a class, that is using object. Similarly, now methods are the part of the classes, so in order to access them, we have to go with the objects. Okay, so now let's check this. So printing the object. Okay, so now if you see, the indentation you have to check. Class time, so class is there, so it has been started where, okay, so the indentation if you check, it is inside, so it means that the print underscore time is inside the class time. Okay, so same thing, what do I do now here is the example, the program what I have taken is simply I'll move this inside, that's it. Okay, so earlier it was outside, see here now the indentation, it is same as the class. Now if I move this further, now this is the entire part is of the, okay, it is a part of the class. Now print underscore time is called as a method, and increment in this case it is called as just a function. So for the simplicity, what do I do is I'll just remove this increment, so just to give you an understanding of the method, how it is being written. Okay, so now this is how we, as I said earlier, okay, so we have to call this a function time dot print underscore time. Okay, so let's run this and check. See now, so what did I do? I have called this print underscore time with the object that is time. So let me remove this and check. It requires, okay, parameter, so I have to give this time. Okay, so the print underscore time is being called with the object time, which is of this class time. Okay, so same thing is being given, shown in the slide itself. Start equal to time, start is an object. Okay, start dot r9, start dot minute is 45, start dot second is 00, and I am printing it, so it is printing the values. Okay, so this is on one of the example of the method here. Okay, so now it is same thing. So what I did is I have moved this, the print underscore time inside the class. Now as we have seen the accessing of print underscore time, there is another way also. So the first way is that we use a normal syntax, that is print underscore time, calling the function normal syntax, and we call it with the name of a class itself. Okay, so that way also works, and the other way is what I just showed you now. Okay, so what did I do? This is the second way. So we use the name of an object and then we call the method. The other way is I can directly use name of a class. What is the name of a class now? It is a time. And to this, what do I do is I pass this time object. See here, so you have to note the difference here now. This is a small t and this is the uppercase T. So this is an object and this is the name of a class. Okay, so this is the second method. So the second method also works how it works in the previous also. Now see here, it is 9:45. Okay, the way how it was working, so same thing it is working with the other method also. So either of these two. Okay, so either you can use this method or you can use this method. So both the way, so your function or the method will be called. Okay, so and by convention, one thing you need to remember in this case is, by convention the first parameter of a method is called the self. So it would be more common to write print underscore time something like this. Okay, so this is very important. So every class which contains a method, okay, so that method's first parameter will always be self. So this can you relate it to this pointer what we have studied in case of C++, right? So this pointer is what, which is pointing to a reference to an object. Okay, so similarly self is like this pointer now. So first parameter always will be self. So this is how we can write it. So let me modify that function and just to show you. Now instead of this, what do I do is I'll make it as a self. Now here also I'll make it as self.r, self.minute and self.second. Okay, so now here in this case, okay, I use the second method. So I use the name of an object and then I call the method. Okay, I will not pass anything now, so then also it works. Okay, so that is how it is. This is very important. So self is a first parameter. Okay, so when we write like this, that is print underscore time start, it means that hey print underscore time, here is an object for you to print. So that is what the meaning is. Print underscore time is a method. To that, what do we do? What do we say generally? Like, here is an object for you to print. What is the name of an object? It is start. And the other way is start dot print underscore time. It says that hey start, please print yourself. Okay, so that is what it is. Okay, hope the topics are clear to you. So in today's session we have come across the second type of a function. It is called as the modifier function, and in order to make the classes like time and date, we have to introduce some of the validations. So those can be done as a part of the debugging. Okay, and we have introduced the assert statement, which does the checking of validating the value of the objects, okay, based on the logic that we have defined in the functions. And then we have seen classes and methods, which is it is a very important topic, because having only an object doesn't make its meaning complete. So you should have a method, okay, which using which the real world entities, we call them as the objects, they interact with each other. So this is on today's session, and in the next session we will continue with the next topics. Till then, thank you.